we're going to be looking at the implicit differentiation. The implicit differentiation, I'll explain it properly so we can all understand exactly what it is. Okay? It's a different way of doing differentiation or finding the derivative of an expression or an equation. But this time around, what makes the implicit function different is the fact that it carries the dy and the dx at the same time. So if I perform, for example, if I have an expression, I have to perform dy, and I also have to perform a separate one, the x, simultaneously. Okay, so I have to do them simultaneously on the same equation there. Okay, all right, so that's exactly what we're going to, and that is implicit function. Okay, so each differentiation, dy over dx, is done simultaneously. So I'll do one, I'll do for x for the same thing, and I'll do for y for the same thing. Okay? Take an example, it will help you understand exactly what implicit function is all about, so you can literally understand it. So let's say, for example, let's take an example, okay? So let's say we have 2x squared y plus, this is just a question we made up, plus 2x cubed y squared is equals to 14x. So this is just an example of a regular kind of thing. If I ask you to find the derivative of something like this, find the differential, the derivative or the differentiation of this. Now, the simple thing you're going to do is just simplify it as simple as you can do it. Right? Use a general rule for this kind of question because it applies here. But if I ask you to use the implicit function, I am simply telling you to perform the operation for x and for y simultaneously. So what do I mean by x and y? Okay. So for taking a look at this guy now, if you find the differentiation of this guy with respect to x only, it's going to be the only guy I can differentiate is what? This guy here, the x squared. Right? So if we find the differentiation of this guy here, I'm going to circle this guy. What are we going to have? What are we going to have? It's going to be 2x. So if you multiply the whole thing together, you're going to have your new equation would most likely become what? 4. Am I correct? Yes. It's going to become 4x. Y. Don't touch the y. The y has no business for now. Then the next thing, I'll focus on the y now. So by focusing on the y, when you use implicit function and then find the differentiation of y. When you find the differentiation of y, for example, you make sure it's going to be what? With respect to what? dy over what? dx. Okay? Anytime I find the differentiation of y, I make sure it is a function of dy with respect to what? dx. So if I have, for example, y cubed, it's going to be what? Y squared. It's going to be 3y squared dy over dx. That is what? Exactly what I mean here. If I ask you what is the differentiation of y, this is just going to be what? Simply dy over dx. There's nothing like 1. Okay, because we're looking at it, the differentiation with respect to dy. So I just have to bring chipping dy over dx there. That's exactly what I mean. Okay, so let's take a look at this same thing again. We've done for x. So let's do the same thing for y. So that's like, as I said earlier, it is simultaneously, one after the other. So we're done for x, let's do for y. So if we do for y, what are we going to have? This is the only guy we're going to be differentiating here, the y. So the remaining thing will just remain the same. So we're just going to have 2x squared dy over dx. It's just y raised to the power of 1. Right? If I have x and I find you what's the differentiation of x, what are you going to tell me? It's just 1. Am I correct? It's just 1. So for y now, y is just 1. So therefore, what if I ask you differentiation, this is what we have left. dy over dx. So when we talk about the y, let it be dy over dx. But when we talk about x, bring it down. Keep going down. For x, keep bringing it down. But for y, don't let y be equals to nothing. Are we clear, guys? Don't let y be equals to nothing. But for x, you can always bring it down as much as you can. So take that notes down. Okay? So let's go to the next one. So we have 3y. Can I do the difference? Can I find the derivative of with respect to x here? Can I find the x? There's no x there.
No.
So the only thing I can do here is what?
For y.
For y. So the only thing I have here is going to be what? Plus, because don't forget the plus sign is going to be what? 3. Put your parenthesis dy over dx. That's it. Look at the next one now. So I put my sign here. Remember, my plus sign is going to be, so I'll put my plus sign. Plus, can I find this with respect to x? Yes, I can, because there's an x here. If I bring this down, I have what? 3, 2 times what? 3 times what? X squared, and then y squared. This is what my answer is going to be. So therefore, it's going to be what? 6x squared y squared. You get it now? So then I'm not done yet. This is for x, but I also have to find the one for y. So it's going to be another plus. So now I'm adding the plus 1 there. I'm adding the plus 1 there. So by adding the plus 1 there, it's now going to be for y. Y is now going to look like this now. So we have 2y, right? So I'm going to be multiplying. This guy is going to be 2y. So in other words, I have 2y multiplied by the whole thing. So it's going to be, for example, 2y is going to be 2 times 2. That's 4. Do you get it now? These 2 times this 2 is going to make it what? 4. So it's going to be 4x cubed y, and then I have what? Dy over dx. I'm not done yet because we still have more. Okay? Well, hold on for a second, please. Just 1 second. All right. So next is equals to, I'll just hold on just for a second. Next, we have 14x. Can I do anything with respect to y there? No, I cannot. I only have x there. So this is going to be equals to what? Just my wonderful 14. If I find with respect to x, right? If I find with respect to x, it's going to be what? 14x. If I find with respect to x, find the derivative, it's going to be 14x, 1 minus 1, which is equals to what? 14x to the power of 0, which is equals to just 14. So that's why we have the 14 here. Don't forget that. Okay? All right, now the next thing we're going to do here, the second rule is to keep all the dy over dx on one side. Keep it on the left side and take the dx, the single guys without the dy's over dx, to the right side. Again, keep the ones with the dy over dx on the left side and take the other ones to the right side. So all the ones that has dy dx will stay on the left side. So let's keep them now. So we have literally have 2x squared. Then we have our dy over dx, close your parenthesis, plus 3. Open my parenthesis, I have dy over dx. Close my parenthesis again. What else do I have? Plus 4x squared y. Open my parenthesis, dy over dx, close, equals to, now let's take this guy. 14 is going to be here, so let's keep 14 here. 14 is a big boy. Let's keep 14 there. Let's transpose this guy. So it's going to be what? Minus 4xy. And then I have, which one do I have left? This one now. Minus 6x squared y squared. Do I have any questions so far? Please ask me questions now. Go.
So the constant will multiply later.
What constant?
Constant of 2x and 2y.
Did I multiply them? Which one are you talking about? Where are we?
It's the one on top under implicit differentiation directly. 2x cubed y squared.
This one?
Yes, sir.
Yeah, the constants multiply each other. Yeah, they do.
Also, that's a given, right?
Yes, you have to do that. That was how we were able to jump from here to here. Yes, Vaughn.
Where did 2y coming from again?
Which part? Which 2y?
Right next to the implicit differentiation.
This 2y?
Yes, sir.
Okay, we differentiated, we found the derivative of this guy with respect to x, and then we found the derivative with respect to y. So for example, if you have 2x cubed y squared, if I ask you what is the derivative with respect to only x, I'm not asking, I'm telling you, please do not touch this y. Are you listening? I'm only asking you to focus on x. That is implicit function. Again, only focus on x and then focus on y simultaneously. When I mean simultaneously, you do for x, do for y, and then you add, and then what sign follows. So if I ask you something like this, the first thing you're going to do is for x, I'm going to focus on x. So that means it's going to be what? What is this? This is going to be 3, right? 3 comes forward. So it's going to be 3. There's a constant here. The constant coming from this number is going to be what? 3, right? So it's going to be 3 multiplied by 2x. Well, this is going to be what? 2 now. Am I correct? Because it's going to be 3 minus 1. So it's going to be square, and then we have a y square. Please don't touch the y. And then, yes, and then the answer is going to be what? 6x squared y squared. Then if I ask you, what's the derivative now with respect to y? Now you focus on the y now. So you have 2x cubed y squared. Now with respect to y, what do you have to do? Focus on only y. So I'm going to be bringing out what? 2 multiplied by what? 2x cubed. Am I correct? Y, not y, because this is 2 minus 1. So it's just going to be y. And then we have your dy over dx. You see that now? So that is how it is going to look like at the end of the day. Are you taking a picture? All right, sorry, can take a picture before I move it. Yes, go ahead.
So y will always be dy over dx, right?
Yes.
So let's say y squared is equal to 2y.
Are you giving me a question?
Yes, sir.
Okay, hold on, let me write it then. Y squared is equals to what?
2y dy over dx. Parenthesis dy over dx.
Can you say it properly?
2y parenthesis dy over dx. That's the correct answer
For which question are you referring to?
Y squared. Yeah. Y squared is equal to 2y parenthesis dy.
Yes. Yes. Y squared is equals to 2y parenthesis dy over dx. Yes, which was, yeah.
So as long as I find the derivative of y, there's dy over dx. Implicit differentiation will always be like that.
Yes, that is correct.
And if it's just y, it's just dy over dx.
Yes. If it's x, just keep going. Keep hitting it. Because the one that we're finding, the input variable is the x, and the output is what? The y. Okay? So there is no shortcut to this. That's why you have it this way. There's no shortcut. This is what it is. So by the way, can we continue now? Bon, have I answered your question? All right, so let's continue now. Please, I'm going to be uploading this video. I'll try to upload it. So make sure you can watch it on your store yourself. That's what I want to do. That's the plan now. Okay? So again, if you have questions, even if you have questions online, just type it online. I will go and watch it. I will go check. I will get notifications of your questions, and hopefully I can answer it. Okay. So let's continue. Guys, you still have questions? So let's continue. Let's finish this out. So the next step is basically to simplify. Okay. Next step, you can actually figure out, research a question and give it to me. Check for any question, give it to me. Let's use the implicit function, implicit derivative, and let's finish this one first. We're not done. You thought we're done? No, we're not done. No, we're not done. Not yet. So the next step here is to simplify this guy. We can factor out the y over dx, which is a common variable for everything. No cell phone. So you can bring your dy over dx. Open your parentheses now. So we have 2x squared plus 3 plus 4x squared y. Close it up is equals to 14 minus 4xy minus 6x squared y squared. So the next step is to divide both sides by 2x squared plus 3, because we're looking for dy over dx. We're finding the derivative, right? So plus 3 plus 4x squared y. Divide the same thing here. So you have 2x squared plus 3 plus 4x squared y. So this cancels this. So automatically, we have our final answer. Dy over dx is equals to 14 minus 4xy minus 6x squared y squared over 2x squared plus 3 plus 4x squared y. By the way, guys, I would like to end here as the final answer, but if you want to go one step further, you can still simplify. You get what I'm saying? You can still simplify the numerator because there's a common variable there, and that is 2. You see that 2 is common for the numerator. But for the denominator, they have no common variable or no common constant.
So do we multiply by 1/2?
No need now. Okay, I'm just saying it's okay to stop this way. It is fine. So this is the derivative. When you use the implicit function, this is the most common value that you are going to get. Now I can entertain questions.
Amen.
Yes.
You will upload the video on YouTube, right?
Yes, I will.
Also, sir, Jim, I just heard a message from Jim. What he said, is there a link to join the class?
For any question, can we move on to the next one? Okay, so I'm not going to be clouding your mind with too many things. All right, so we're just going to have only 2 examples because implicit functions are rare, happens only on rare occasions. All right, but I just want you to, I just want that memory should be there. Okay, so let's go on. Clairboard, another question. Sure, no one has a question, no one has a clarification. Did you see any question that you want us to solve? Did you see any you want us to solve using implicit function? Or you want me to bring something more difficult now?
Oh,
All right, let's take something a bit more challenging. So let's see 3x cubed y to the power of 5 minus 2x, because the first one was all positive. So what if we have negatives now? Right? My plus 13. Right? If we have like plus 13, uh plus 13 x minus all right. So let's continue. Plus 13x minus 8 minus 8y equals to 14y squared minus 2x y. Can you see it's long? Plus 3. Very long.
is that why then, sir?
Yes, y to the power of 10. That's a long question. Okay, this is a weird question, but that's why I said give me your own question. But no one gave me a question, so I'm giving you a longer one. Can we go on?
Yes, sir.
All right, so what's the first step? You find using implicit function, implicit derivative or differentiation. Again, you have to find with respect to x and y. So with respect to x, what is this going to be?
6x.
This is it 6x or 9?
That's like
9x squared
is that 3?
y to the power of 5. Plus sign here, so it's going to be plus. You have 5 times 3, you have 15. Are you with me, guys? 15x cubed y to the power of what? 4. And then have my dy over my dx. Close my parenthesis. And then what is my sign going to be? It's a minus sign. So because of this negative sign, it's going to be what? Negative.
Oh, wait.
Are you guys with me? Are you confused? Okay. So here, with respect to the x, with x, it's going to be what? 4x y. Then my minus sign again, because this is still minus, it's still going to be what? Minus. Okay? So this is going to be, now there's, look at this guy here. This is just this one. So it's going to be what? 2x squared. Do you get that? I mean, this y is just one y. So I'm just going to have what? dy over dx. Don't get it confused, okay? That's how it is. That's what it is. So I'm just going to make sure I put my 2 there so no one gets confused. So we're done with this guy now. So let's move to this guy. So this is a plus sign. So this 13 has no y. So it's only x. So I can only do the one for x. So this is only going to be what? Just the 13. Are you with me now? The derivative of 13x is just 13. And then next, Jed, confused? You're explaining to him? You confused?
I'm just telling you what I think.
Okay. You should let me know in case you're confused. Are you confused? You're not? What are you thinking? What? Share.
Trying to relate the things that we learned from this
Okay. All right. So 13. So this is going to be then minus. This is 8y. So this is going to be minus 8. And then what do I have? dy over dx only. Close my parenthesis. Yes. You have a question? You raised your hand. That's your in there. All right. So this is equals to. So long, right? So this is equals. If you're not careful, you're going to take time with questions like this. So this is equals to. This is 28. What? Y dy over dx. Close your parenthesis. Then what do we have? Minus. This is going to be what? 2y to the power of what? 10. Right? And then minus again. Oh God, it's such a long question. Let's make it smaller. I'm gonna make it smaller. Okay. All right. So 2y. What else do we have? Yes.
Is there a square 14?
Where?
14 by 14y?
There's no 14y here. 14x squared. Where's 14x squared? That's 14y squared. Look at it. It's 14y squared. Where were you when I was writing the question? You were thinking of something, right? You saw that the back here. All right. So 2y. So what do we have? So we do for the y. So that means we have 20x y to the power of what? 9. Open the parenthesis dy over dx. And then we have what? What do we do with the 3? You still want to write the 3? What's the derivative of a constant?
0.
It's 0. We don't need it no more. It's gone forever. Don't let it confuse you, okay? It's just a confuser. It's a confuser of words. All right, now we have a very long guy here. All right, so again, we follow the same process. We put all the guys with the dy over dx on the left side, right? And then keep the ones without the dy's, without the derivative functions there on the right side. That's exactly what we're going to do. So let's go ahead and solve. So I'm going to have this guy first. So we have 15 x cubed y to the power of 4, open the parenthesis, my dy over dx, close it up. And then I have, since I'm done with this, I take this one as well. Minus 2x squared, open a parenthesis, dy over dx, close. And then I have my minus 8, this one now, open a parenthesis, dy over dx, close. I take this one now, this is going to be minus now. Can you see that? So minus 28y, open a parenthesis, dy over dx, close. And I'm going to take this one as well. So that is going to be a plus 20xy to the power of 9. Open my dy over my dx, close. So now I can take this one now, checkmate. So this is equals to, what is the first positive, dude?
9x.
So let's have negative
9x squared.
9x squared, 5y5. What else do we have?
Plus 4xy.
Plus 4xy. What else do we have? So checkmate, minus 13. Can you see that? Minus 13. What else do we have? Minus 2y to the power of what? 10. What else do we have? Yes.
So that's supposed to be plus y
Which one?
by 10.
Which one?
The one you just wrote.
Huh?
The one you just wrote just now.
Minus 2y to the power of 10. It's on the left side. It's on the right side. So there's no moving it anywhere. Look at the equal sign.
What is the equal sign?
The equal sign is there. Let's change the color. Look at the equal sign. So please don't get it confused, okay?
Wait, that was negative. That's why the x became positive.
Yes. The ones on the left side, I moved it, I transposed it. The ones on the right side, I left them there.
Why? Okay. I know.
All right. Oh, good, everyone. This is a method that no one of you would like. I know that.
Oh, we love it. Sir.
Jed, do you like this? I think you're joking.
I like it. It's actually easy to understand. Yeah, it's easy to understand. It is really long. Yeah.
It is.
It's writing.
Imagine the space that you need to write this kind of question. All right. All right. So, JM, are you there? I hope you're there. Just maybe give a thumbs up, okay, if you're there.
Yeah.
All right, JM, give us a thumbs up. All right, so let's continue. So let's factor out. So we have dy over our wonderful dx, open a parenthesis. So we have 15 x cubed y to the power 4 minus 2x squared minus 8 minus 28y plus 20xy to the power of 9, close my parenthesis, is equal to, let's rearrange this guy, okay? So we can have 4xy, am I correct? Minus 9x squared y to the power of 5 minus 13 minus 2y to the power of what? 10. So what do we do next? Divide both sides by this dude here, by 15 x to the power of 3 y to the power of 4 minus 2x squared minus 8 minus 28y plus 20xy to the power of 9. Do it on the same side as well.
There are like terms you would combine them, right?
If there are, if you want to, sure, why not? So this one automatically cancels this. So our dy over dx automatically becomes, I hope I can push it up here.
Maybe just put equals to dy over dx beside that.
Pardon?
Maybe just put equals to dy over dx there, like beside that, right?
So I put it on the right.
That's what I mean.
I should just go to the right and then put it here.
Yeah. Let's say dy over dx.
I need na.
Maybe faster like that.
I need na. We're almost, I think we're almost, okay. So anyway, please check I need a question from you guys. Give me a question. Please check your computer, check your phone. Give me one of the questions we've solved. Let me solve it using the implicit function. You don't want it?
You don't have any questions? I'll like this.
You all understand this? Because you're gonna have to solve one on your own now. So 4. So what do we have? So dy over dx is 4xy minus 9x squared y to the power of 5 minus 13 minus 2y to the power of 10 divided by 15x to the power of 3 y 4 and minus 2x squared minus 8 minus 28y plus 20xy to the power of 9. So that will be your final derivative function when you solve the given problem. Do I have any question from you? Yes, Vaughn.
If you were to come up with, well, before we answer one in ourselves, can you come up with a question that's not much time consuming, but it's more difficult?
You want to try one by yourself? Something easier?
Something that's not much time consuming, but it's much harder.
Okay, so let's take a look at something here. You want to try something. So let's try a quadratic, let's try a cubic function, a cubic equation. Right? You want a cubic one, so maybe a we can try that type of equation. So we can say something like um 5x to the power of 3 minus 7x squared, 7x squared y cubed is equals to 14y plus 2xy, 2x to the power of 2. So I think this is quite easier and shorter for you all to solve. So guys, please solve this, okay, using the implicit function, implicit differentiation method.
Is that 2x squared?
Pardon?
Is that 2x squared?
Yes, 2x squared y squared. I can make it bigger if you want. This is it. Okay.
Look,
All right, so please, sometime, please let me understand the difficulties. If you cannot chat with me face to face, chat with me online as well, okay? Yes.
can you put the link that is
So is that 7x?
Yes, that's 7x squared y cubed. You want the link? No.
Where can I see from here?
Oh, you didn't ask me for the link earlier. Sorry na. Sorry na.
That's a good one. Okay. I was on plug it. Name of the class. That's parang ibig. Oy, ito ko ano siya baka Ay, naman po ako na.
much of our time. So, all right, for this question here, this is quite straightforward. Let's listen up. You're talking. Listen. Instructions is so hard to follow. Okay, so this one here, we can only have dx, right? With respect to dx. So this is going to be 15, 15x squared. So the next one will be minus, don't forget there's a minus sign. So we do for x, who's talking? So we can have 14x y to the power of 3. Then we can have the negative minus again. And then we can have, and then next we can have, with y, we can have 21 x squared y squared dy over dx. That's very good. You all are following. So here I can only have 14 dy over dx. Very good. You get in the concept now. Plus, both, I can have both here. So I can have 4x y squared plus 4x squared y. All right. So I think you're literally done. So now you can just put them together. So the only guy that can stay here is one dude here. So anyway, since this is positive, let's just take everything here. What is it?
Separated with an equal sign.
There's an equal sign here. Can't you see the equal sign?
I can't see it. No. I didn't see a negative sign.
All right. So let's, in this case here, we can have the, it doesn't matter. All right, we're just going to try and make the dy over dx positive. It's okay. So we can leave it, in this case, we can leave it on the right side. No problem. let's
Stick to the no.
let's stick to the rule.
Yeah.
Okay, whatever you want, I'll follow. Okay, I'll follow the rule. Okay, so we have minus 21. Okay, minus 21 x squared, pardon me. Let's the eraser.
So is it okay if we interchange the dy over dx? So it'll just be different symbol.
What do you want to change it to?
Like the dy over dx will be in the left or right. It doesn't really matter.
It doesn't matter for now.
It'll just have different symbols. Like different negative and positive signs.
You have to multiply everything by -1. Cannot
Negative
change. Yes. So follow. All right. So followed by sorry for the silence. All right. Followed by next we have x, okay, square, y square. Do not forget your dy over dx. Very important.
Minus 14.
Then we can bring the other guy. So we have minus 14.
1 over this.
You have your dy over
Minus
dx.
4x squared. Yeah, don't push yourself.
It's math. It doesn't matter.
Matters.
Okay. I give up. I give up on all of you. Sometimes you just gotta follow students. Sometimes you gotta follow your students. Otherwise, they won't agree.
minus 15x squared plus 14xy cubed.
Anything else?
Nanaking
Let's check. Okay, everything's gone. So now we can multiply. Wait, we can multiply all through by negative sign. By negative one. So you get, if you multiply by negative, or you divide all through by negative one. What do you want? So we can have 21. If you multiply 21x squared, y squared, and then you have your dy over dx. It doesn't matter. That's why I said it doesn't matter. Plus,
all of the signs are
yes,
are corresponding.
yes, dy over dx. Then you can have plus 4x squared y, your dy over dx, and then this becomes minus. I'm just going to rearrange, okay? So this becomes minus. Instead of minus, we can have plus na lang. Or let's have minus 4. Let's not confuse you guys. Plus 15x squared minus, okay, minus 14xy cubed. Any confusion so far? Any confusion so far? All right, so we can continue already. So we can bring out the y over dx. Open up. So you can have 21 x squared y squared plus 14 plus 4x squared. I'm gonna put this xy, then my y here. Close my parenthesis is equals to rearrange this guy to be 15x squared minus 4xy squared minus 14xy to the power of 3. So divide both sides by 21x squared y squared plus 14 plus 4x squared y. And then the same thing here. Did you guys all get it right?
Yes, sir.
I thought you guys had problem with the sign. By the way, we just formed this question now. Yeah, and that's good. So 4x squared y. The good thing about calculus is it's a model. All right, it doesn't matter. You might be modeling a system exactly, and you may want to find the most optimal solution for that system. So that's exactly what we keep doing when we talk about derivative. So it's cool. Math is really cool as long as you understand exactly what you're doing. So once this dude cancels out this dude, so we're left with our beloved dy over dx is now equals to, do we have any common ground here? No, we have no common ground. The bottom, we have no common ground. So let it be. I'm not supposed to just form question in math, but please forgive me. That's how my brain works sometimes, okay? I am not allowed to do that. I don't think I'm allowed to do that. All right, so literally this is the solution. All right, if you got it right, you got it right. There's no two ways about it. Any questions so far? Yes, Vaughn.
Why did this come for?
All right, so thank you everyone. If you have questions and you're online, if you have questions, please just give me a chat in the comment section, okay? Hopefully I'll get in touch with you. Thank you. Have a great day.